Okay, so we're back. Um, you can see there's a few new additions to the robot. First thing was I went through and I just blew out the sim motor setup and put a couple of Neo 550s with some gearbox. I put a two-stage gearbox on them. And then the other thing I did, uh, as I said, I kind of wasn't happy with how the components got all laid out. So I went through, relayed things out. The big thing I wanted to do, because in our hypothetical robot, this whole area right around here um, was at risk for contacting the cube. So I wanted to clean all that out. And then, if you recall, I had said I wanted to figure out a way to tie the two uprights together on our pivot. And lo and behold, we can go ahead and use the PDP to do that. We're turning the PDP into a structural member. I don't think there should be an issue with it. So what we would do is we would transfer these holes, put some rib nuts into the 1x2 or 2x2, and go ahead and bolt that, and that ties these two together. But this video, what I wanted to do is go into a little bit more part creation. So this is something we can't do from scratch or do just copy or download a file. So the first thing I wanted to do was, if you recall, we put this 1x2 in to help us serve as a hard stop for our uprights or for our intake. But to do that, we have to fill in this gap, probably about an inch, inch and a half. So what we're going to do is I'm going to turn off these swerve modules so we can get a little bit better view of it. There. So what we're going to do is do a little, like a bumper, if you will, with maybe a little bit of a V-guide in there to help guide this down into a repeatable position, both in angle and then as it comes down, nest into a nice little slot. So this is something that we could design and probably 3D print out of TPU. Our team's getting really into 3D printing. So yeah, we'll go ahead and do that. Okay, to start off this part, we're going to create a sketch, and we're going to create it on this plane so that we know exactly where to start it from. So right now we're on that battery, that 1x2 that spans the width of the robot. So to help us locate where we're going to put this part, we need to transfer some or project some components onto our drawing. So the easiest one to do would be to project these two, the edges of our polycarb. So I'm going to type P to project those profiles. And I select them both and then click on OK. So now what we have is a decent a cross-sectional view of those two parts. Now what I'm going to do, because what I'm going to do is essentially work on one side of this and then mirror it about, so I get the exact same thing on both sides of the polycarb. But to do that, I need to create another line here so that I can generate this midpoint that you can see I've kind of brought up there. Okay, so that's first. So we know this is about as far as over as it needs to go. Now what I'm going to do here is, off the edge of this, I'm going to come out a couple millimeters, maybe 3 millimeters. That'll give us like plus or minus 3 as we're coming down into our detail. So I'm going to come over about 3 millimeters, And then the other thing I'm going to do here is come up. It doesn't have to be perfect, and it doesn't have to be any specified angle. Just you want a little bit of a V guide, so that when this comes down in, you get a little bit of engagement. So we'll go up there. We'll come straight down, or straight across, I should say. And then I'm going to come down. Well, first thing, we'll do it right about here. The other thing I want to be able to project this up, or this edge up, so I can make a nice mounting flange on either side. So I'm going to hit P to project again. And I'm going to select that top surface there and then click OK. Now what I want to do is I want to offset that line so I get a nice flange that I can put some bolts down through. So I'm going to offset that line. I've already got it selected. We'll call it 5 millimeters. Should be thick enough. Okay, so now I've got my flange, but I need to extend this line down to the flange. So I'm going to come up here and hit the extend command. And you can see the red line means it's going to come down over. Then finally, what we need to do is off of this line, come down and finish our mounting flange. Okay. The last thing we need to do before we go ahead and mirror this is trim off some of this excess. So I'm going to trim that line and that line. Don't worry about the constraints. Okay, so now to mirror in the sketch, we have to give it a line to mirror it about. So we're going to mirror right about the midpoint. So I need to create a line, but what I'm going to do is I'm going to turn it into a construction line. So that way Fusion knows it's not actual live geometry. We'll do that, and you can see it's a hash line. And then we should be good to go, to mirror at least. So now I'm going to hit the mirror command, and I'm going to select all those lines I just created. So I've got this profile. Now I need to select the mirror line, and you can see it's created it all over here for us. So now the last thing to double check before you go ahead and exit the sketch and extrude this is to make sure it's a closed body. To do that, you can barely see how it goes very, very light blue when I hover over this area. Now, if I clicked in this region, it goes to a much more readable blue. And that way you know it's a fully closed body, and you can successfully extrude that. So I'm going to finish that sketch. And then just pivot down a little bit. And now we can go ahead and extrude. It's already been selected. So I'm going to extrude that. And what I'm going to do is -1 inch because I need to go back. -1 inch. And then I'm going to create a new body. And that looks pretty good. So again, what we would probably do with this, I'm going to turn off the intake. I wouldn't worry too much about this. This is because we had projected the side view of the polycarb. It's just an extra face in there. It should be fine. But again, what we would do is we would take this and throw it on a 3D printer. We do need to add some holes in here. Okay, so now that we've got our bumper created, we do need to create the mounting holes. So to do that, I'm going to create a sketch on that mounting hole. Okay, so I've selected the mounting flange. And then what I'm going to do is I'm going to create a circle. Now what I'm doing is I'm hovering over the midpoint of that edge. I'm not clicking yet. You can see the triangular. That means the triangle that's over my cursor. That means midpoint. I'm going to make sure I can drag drag that down a little bit. You can see the light blue hash mark there. That means I'm tracking the midpoint of the top edge. Then I'm going to come over here, do the same thing. I'm not clicking yet. Hovering over that midpoint, and then when I come over, it should snap right there to the midpoint. So what I've done now is I've tracked the midpoint of the top edge and come over from the midpoint of the left edge, and that will snap directly to the center of this little mounting flange. So now is where I can go ahead and click. And I believe I'm going to make it a 2/10 hole. I believe that's a good clearance hole for a 1032 bolt. Don't quote me on it, but I believe that is what it is. So it's a diameter of 0.2 inches right there. And then we're done. Okay, so now what I'm going to do is go ahead and extrude this down. And we'll just say -5 millimeters because that's how thick we made this. Now to double check that we're not cutting into the aluminum. We're not. We're only cutting this body 10, which is what this bumper is called. We're going to click on OK. So now we have our mounting hole. And then we're just going to do the same thing over on the other side. So again, I'm going to find my mounting ear or tab, select a circle, hover over the midpoint there, hover over the midpoint there, and then it snaps to the middle, 0.2 inches. Finish the sketch, extrude that down, -5 millimeters. Check our objects, and we're good. So there, we'll turn our intake back on, see how it looks. Looks pretty good. The other thing we might want to do here, and we can do it right now, is soften up some of these edges. When you're 3D printing something, layer lines are always going to be the weak point. So now we could print it with this side on the build plate, which would be actually probably the strongest way to print it. The only risk is as you're coming up, if this is on our build plate and we build up towards the front of the robot, if you will, these holes might end up being a little not very good. The other way to do it would be if we were to build it from this surface up. We now have a layer where this edge meets this layer line. That's a weak spot. And the same thing in here where this edge meets this surface. Again, that would be a weak spot in our layer. So what we'll do is we'll just go ahead and fill it and round some of these edges off a little bit and to try and eliminate some of those weak spots. So I'm going to hit escape. So I'm going to fill it this edge and this edge. We'll see what 1 millimeter, not a whole lot there. So let's make it a 3 millimeter. That looks a little bit better. And then we'll do the same thing on the inside here. Fill it, that edge, 3 millimeters. That looks pretty good. And again, it gives a little bit of a ramp. So if in case those arms do come down off, they'll come in and hit this surface, and then there'll be a nice smooth transition to get centered back up again. Okay, so now the last thing we need to do, let's dissolve those commands. And then there's our body. We wanted body 10. So I'm going to teach you a way to mirror bodies. Okay, so now what we're going to have to do, we haven't done too much of it, is with construction planes and construction items. So basically, these are just temporary helpers that will allow you to do all sorts of things. Make a sketch in a weird angle relative to the robot, imaginary axes, those sorts of things. So what I'm going to do, the one I've used the most is what's called a midplane. And that's this command right here. And basically what it does is that you pick two planes that are in the same orientation, and Fusion360 will create an imaginary plane that's directly in the middle of them. So basically we're going to create a plane that's directly in the center line of this robot. So to do that, I'm going to click on this mid plane. Okay, so it's asking me what planes I want to use. So we want to find the center line of the robot. So I'm going to select, this is the outer frame. So I'm going to select that plane. And then I come over here and select this plane. And you can see in yellow, we've created an imaginary helper plane. Okay, and you'll see why that is necessary in a second when I show you how to mirror this. Okay, so we created this imaginary plane in yellow, and to check what planes you have, all your construction helpers are up in the product tree under construction. Okay, so if you create a line, a point, a plane, anything like that, they'll show up, and you can turn them on and off, turn the visibility on and off. Okay, so now that we have that construction plane, the center line, we want to make sure that this part, our bumper that we just created, gets mirrored exactly about the center line of this plane, or the center line of the robot. So to do that, I'm going to select it in the part tree, and then I'm going to come up to create, and then I'm going to come down to mirror. So this allows you to select faces, bodies, features across the plane. Okay, so I'm going to select mirror. It's already got my part selected, and then mirror plane. Now what I can do, because this plane is kind of hard to click on, I'm going to come up here and select it in the part tree. And there you can see the outline of the part that we are mirroring. Okay. So once we do that, we're going to make sure it says new body and click on OK. And there's our part. Actually, it looks like we might be a little bit off-center. Those arms might be a little bit off-center relative to the center line of the robot. Because if you look, I just have a very, very small amount over here from the edge of our fillet to the polycarb, or if I come over here to the other side, it should be shadowing this line. So what we can fix it if we had time. Not a big deal, because all it would take is moving the whole intake, what, probably about, oh, it's about an eighth of an inch. It's an eighth, or actually a 16th of an inch off. So that's not for this set of videos. Okay, so we've got that part made. The other thing I did want to get into was I wanted to figure out a way, even though we're going to use this PDP as a kind of a structural member for this upright, I did want to create some more strength back here. So we might go ahead and do that, or we might go ahead and finish the triangulation of the intake by coming from here, or maybe even here. We can't go there because of the belt, so it's got to be this surface or on the inside. Okay, so we are nearing the home stretch with mechanical design. The last thing I wanted to complete was the upright support. So we got these pivots. As of now, the only thing holding them in is they're being attached to the front cross plate. So what I wanted to do was kind of triangulate coming from the back of this, the uprights, down to the belly pan. So basically, all I was thinking, I'm going to turn the intake off real quick and just think a 45-degree arm, probably land it somewhere between the two pulleys, above the PDP, and come down at a 45-degree angle. But to check and make sure we're not going to be in the way of anything in our pivot, I'm going to introduce a feature called a section view. So basically what a section view, for those of you who aren't aware, it allows you to cut a plane, any sort of plane, and basically make anything in front of the plane invisible. So you can actually look through parts. So I'm going to turn on the intake, and then what I'm going to do is come up here to the inspect menu, and down here is section analysis. So basically what I want to do is I'm going to use the side of the pivot upright as my plane. So basically everything in front of that pivot, in front of that plane, is now invisible. You can offset it if you want. You can drag it through, so we can drag it one way or the other. But for right now, all we really care about is that surface. Actually, we'll go in 10 millimeters. So then we come to the right side. So I'm looking, and roughly there doesn't appear to be much, if anything, in our way. To verify that, what we'll do is we'll just create a sketch on this plane, and we will we'll project some components using the P command. So I'm going to project that line and that surface, basically the bottom side of the belly pan, and click on OK. And then just to be able to see everything clear, I'm going to turn most of this stuff off. I did a little bit more organizing. If you look at all those electrical components, I hid in a folder called electrical. So then what I'm going to do is I'm just going to create a line. Actually, let's turn on the pivot upright so I can see where my axles are. And then I'm just going to come down here, roughly between the two axles. I'm going to start a line, and I'm going to come down at 45. I'm going to constrain that at 45 degrees, and just come down to the belly pan. Okay. Then to what I'm thinking is, because it'll be a little bit easier to work with some a 1x1 extrusion, because what we can do is make a custom mount that will work on both this side and this side. You could also do it straight up in 1x2, but then you start to run into some issues as far as mounting it to the sides, because we can't come on this side because that's where our belt is. So what I'm going to do now is just offset this line ½ inch, so 12.7 millimeters one way, and then going to offset it again 12.7 going the other way. So that gives us our 1 inch minus 12.7. Okay. Then I'm just going to finish the box there. And then I'm going to finish this sketch. Then to actually make the 1x1, I need to extrude both of them, because there's two closed regions in there. And then I'm going to make that 25.4. And I'm going to, miss that part, and we missed that as well. Okay, so we're going to make a new body. It's basically just going to be a 1x1. And the reason it disappeared on us after we hit the OK command in the extrude is because it's on this side of our section plane. So let's come up here to analysis. So when you create any section, anything that comes in this inspect command is hidden in this analysis part of the tree. So we're going to hide that, and there's our part. Okay. Now, just to get it in line, basically we want it centered side to side on the 1x2. I could do a whole bunch of point to point and all that jazz, but I'm just going to measure. I'm going to turn on my snap points. Select the center line there, and then the center line down there. I'm going to turn on the coordinates, and I'm going to look at the top view. So what we want is the X dimension. That's 229.406. Okay, so let's come in here for that body, move it. That 229.406, and it's got to be a negative. There. Okay, so that is pretty much centered. So now the other thing we want to do, because this is an extrusion, we do need to shell it. So let's shell that on both faces. So now this stuff is a little bit thinner. I think you can get it in both 1/8 inch wall and 16th inch wall. We'll just go with the 16th inch wall for now, which is 0.0625 inches. And then hit OK. And then what we're going to do is turn everything back on just to make sure we're still in the clear. Don't worry that this extrusion runs into, crashes in here and here. We'll fix that in a little bit. Okay, so we're back in the side section view. I turned the intake back off. I think the next thing what we'll do is we'll fix the length of that extrusion we just made. Because it's a really messed up dimension as it is now. Whoops. Let's measure the edge. There we go. It's 12.043 inches. I don't think anybody can get down to the 100th of a decimal point. So what we're going to do is we're going to make this something that's easily manufacturable, and we'll take up some of any of the slop once we start making the mounting pads. So let's go ahead and shrink that down to something easy. So first things first is let's get rid of that 0.043. It bugs me. So we'll press pull, and then we'll do that edge. There we go. So let's pull up our calculator. So what we're going to do is we're going to shrink both sides by half of the 0.043, just to make sure we maintain center to center. So 0.0443 divided by 2, 0.0215. So minus 0.0215 inches. Press pull. That minus 0.0215 inches. There, that one. Come down here and do the same thing. Press pull. There, minus 0.0215 inches. Okay, we'll double check our work by measuring that edge. 12 inches. Okay, it's still not enough. So let's take about maybe 3/4 of an inch off either side. Again, we'll make up a lot of where I'm going with this mounting bracket. We'll make up for a lot of this slop. So once it's fabricated, okay, or once it's designed. All right, so we'll take off 3/4 of an inch there. Minus 0.75 inches. Let's see, is that enough? That should be good. And then we'll come down here and do a 3/4 of an inch shrink. My computer is running slow today. There we go. 0.75 inches. There. Okay, so we have our aluminum structure, or aluminum 1x2. It's now an easily manufacturable dimension, 10.5 inches. So then what we're going to start doing is we're going to start creating the mounting pad or bracket for this. So what I'm envisioning here is something that takes up the whole 2-inch span of the upright, and then we're going to do what's called a loft that will project itself to the cross section of this tube, and will capture a significant portion of the tube. And I'll explain where my head is at once we get this part lofted, how we'd go about manufacturing it. Okay, so to do that, the first thing we do, so basically a loft is when you have a sketch on one plane or surface, and then you have another sketch that is on a different plane or a different surface. What a loft does is Fusion will automatically create the geometry that connects the two. So basically what we're going to do is we're going to say, okay, hey, I want this mounting pad over here on the upright. And then I need to mate up with a surface. And we might, the more I think about it, the more we might have to shrink that another, that aluminum tube another 1/4 inch on either side. But what'll happen is then we'll create a sketch down here, and we'll have Fusion fill in the blank. Okay. So before I forget, though, I do want to make this even a little bit smaller. So we'll take another 1/4 inch out, minus 0.25 inches there. And then we'll do another minus 0.25 inches there. There. So now we should be at 10 inches on this edge. Yep. Okay. So the first thing we're going to do is create a sketch on this plane. Okay. So then what I'm going to do is I am going to project the center line project this tube onto this surface, just so I know where it lands. Okay, so what I'm going to do is come back over here. I'm going to type P to project and select that surface there. Okay, so when I come back around, it didn't do what I wanted it to do. Okay, I know why. No, I don't. Okay, I had thought about doing a loft with this mounting bracket, but then the easiest possible way we could do it is just literally revolve or do a sweep from this surface down to match up with this surface. So we're going to do it from the side view. We're not going to do a loft. So to get started, we're going to create a sketch on this plane. And then to figure out how big our sweep is going to need to be, I need to project some geometry here. So I'm going to project this surface as well as this surface and then hit OK. Now, to figure out like kind of where this stuff works, or where our center points of this arc that we're going to sweep needs to be, I need to extend this line down to that surface. And it's not working. So we'll create a line from there at 135 degrees. Again, because remember, we're at 45 degrees. So this is the center line where all of our sweeping will happen. Now, the other thing we need to do is, and we might end up playing around with this sketch a little bit, but I need a fairly solid mounting foot. So I'm going to select that center line there and just kind of come up here. Again, we don't have to be exact where it's going to be, because we'll fix it in the interim, or fix it after. So we'll make it about 5 millimeters thick, and then we'll call it right about there for now. So then the other thing we need to do here is start figuring out where our sweep is going to be. So again, we want a nice, if you want to call it a bite, engagement. So I'm going to project that, or not project, I'm going to offset that line, another, we'll call it 5 millimeters on that. And then I'm going to offset that line as well by 5 millimeters. Offset 5 millimeters. Okay. So then what I'm going to do is I'm going to just start creating circles. Okay, and I'm going to go from here to there, and there to there. Okay, and we'll trim up some of these guys. That, and that, and that. And then we'll trim this and this. We don't need that anymore. We don't need that anymore. We don't need that anymore. Okay, so you can see roughly how this part will look. But the other thing we need to do now is how much engagement down the length of this 1x2 or 1x1 do we need. And I am going to make it very healthy. I'm gonna make it almost probably about an inch and a half. And I'll get there, I'll explain why in a minute. So we're going to select that line, and we're going to offset that. So that's about a 1/2 inch. That's roughly 1 full inch. Yeah, we'll come down here. We'll call it 1.5 inches. Oops, wrong way. Minus 1.5 inches. That looks pretty good to me. Okay, but then the last thing we need to do is I need to extend those lines out to our outer lines. So I'm going to extend that and that. Okay, so now you can see we have a closed body. So the last thing, I'll trim that guy up. Okay. So we're going to do a couple different steps on this extrusion. The first thing we'll do is we'll extrude this mounting pad the full 2 inches. So we'll finish that. So I'm going to extrude that. Let's make sure we're going in the right direction. So minus 50.8 millimeters. Why did that not happen? So we're going to extrude that minus 50.8 millimeters. But we're going to create a new body. Everything we're going to be doing here is going to be all about creating new bodies. Okay, so step 1 is so far so good. Now let's look at our sketch. Where'd our sketch go? Okay, you can kind of see our sketch is off in the middle of nowhere. That's okay. But what we're gonna do is we'll extrude. We're gonna do a couple of different extrusions now. The first thing we're gonna do is these walls. Let me think about that. Yeah. So what we're going to do is we're going to make 2 individual walls, and then we will move them into position, mating that surface up. It's probably not the most efficient way to do it, but that way we'll know that our wall thickness is accurate. So if we remember, we said we were making them 5 millimeters thick. So minus 5 millimeters. And again, new body. And then click OK. Then what we'll do is that body we just made. Well, we'll wait. So now we can move this one. You can see. Okay, we've got a good bite on this bracket or on the structure. So then what we can do now is just measure surface to surface how far off we are. We could do it math, but this is easy. So we're 7.7 millimeters off to get it to line up. So let's come down to our body. So that's the one we need to move in that direction, minus 7.7 millimeters. Okay. So you can see we're now lined up with this outer surface of the aluminum. So now we'll just create a copy of it again, and this time we have to go the 12.7 plus the 5 millimeters. So minus 22.7. That ain't right. Oh no, 1 inch plus the 5 millimeters. So 25 point, so minus 30.4. There it is. All right, so we're almost done. The last thing we need to do is fill in this gap with the top and bottom, if you will. So what I'm going to do is I'm going to do one of these. So first thing I'm going to do is measure. This should be 25.4. 25.4. Okay, so then what I need to do is extrude this portion again, 25.4 mils. Let's just go 25.4. We'll create a new body. And the hatching is showing up strictly because it's going through our analysis or our section view. So now let's move this into position. Actually, we'll just do, let's select that body, move it, and we'll do a point to point. We'll go whoop, there to there, click OK. So I'm going to turn the sketch off for a minute. So you can see now how we went about creating this whole thing. Okay, eventually what we'll do is we'll do a join command to join all these parts together into the one solid piece. Okay, so now we can start joining all of these together, and we're going to add a whole bunch of chamfers and fillets, but I'm going to hold off on that because we have to consider where the mounting holes. We don't want a chamfer or a fillet interfering with our mounting holes. So to join all these bodies together, I'm going to come up here to modify and combine. So now we've got our mounting foot, and then we just go ahead and start picking the other 3 parts, and we'll click on OK. Okay, so if I turn the aluminum structure off, you'll see we've got a nice pocket down there for the aluminum to go into. Now, the one thing you have to take into consideration is 3D print tolerances. I guarantee if we threw this on a printer, which is the intent I had, would probably print it out something strong, ABS or nylon CF12. Printers aren't perfect. You have to make some accounts for tolerancing. So to do that, generally what we do is about 0.15 millimeters. So what I'm going to do now is I'm going to press and pull all these surfaces. I think I can do them all at the same time. We'll try. And then what I'm going to do is take off minus 0.15 millimeters. I think that worked. We'll measure it just to be safe. So that's 25.7. And if I turn the aluminum back on, there should be a very, very tiny gap in there. And it's hard to see. We know it's there, though. Okay. Okay, so the other thing we have to consider is this, again, with a 3D print, if we were to print it in this orientation, like so if this is our build plate down here and we were to come up, this joint where this meets our mounting foot is an inherent weak point because that's a layer line. So what we need to do is really beef up these edges so that we don't create what are called stress risers. So we're going to go ahead and start filleting those, but we have to take into consideration we need to add some holes, at least on the top side. I don't think we'll be able to, we might be able to fit some down on the bottom. Probably not. Would probably end up just having to deal with mounting holes only on one side. Kind of stinks, but that's the nature of working with some of this stuff. So what I'm going to do is just strictly measure from there to there. Now we got about a ½ inch. We might need to lengthen this top edge up about another ½ inch. So let's go ahead and do that just to be safe. So let's just 0.25 inches there. All right, so then we can start making some fillets here. So we'll fillet this surface. You can, when it comes to filleting, you can either select a surface, and in this case it'll select all 4 lines, or you can do individual edges. So let's start playing around with seeing what happens with our radius. So a 3 mil. So you can see here it rounded off the both edges. Will that look okay? Actually, you know what? I'm just going to do the individual edges first. We're going to fill it that, and that. We're going to go with a healthy 4 millimeters on that. I mean, realistically, we could have made this a little bit bigger, but we do kind of want to round that off as well. So now I'm going to do this edge, essentially all these edges with slightly smaller one, just to soften it up a little bit. And then the last one I'm going to do is I'm going to do the whole other part of our sweep. So I'm going to fill it this, that. We'll see what 2 millimeters looks like. That looks pretty good. Now the other thing to help out as far as installing this aluminum, you probably want to chamfer or fillet or chamfer this top edge. It doesn't have to be a lot. It could be literally like a 1/2 mil, but it will, if you got any burrs on the aluminum from cutting, it'll help slide that aluminum in. So we'll do that. Let's turn the aluminum off. So I'm going to fillet this edge, this edge, this edge, and that edge. Just do 1 millimeter there. Okay. So that is essentially our mounting bracket. The last thing we need to do is add some holes up here. You'll see up here, Fusion has a hole command. It's absolute junk. If I hit this hole, there's no way I can't track any significant points in any. So if I select that surface, the only way I can move it around is there's no measurement. I can't snap to any tracking points or anything. So we have to create those tracking points. Okay. So to do that first, we have to create a sketch on that plane. We want them spaced fairly nicely, right? So then what I'm going to do is create a line. Actually, let's project that surface. Okay. So the first thing I'm going to do is come up here, find the midpoint, come up to the midpoint, and then I need to do the same thing. The midpoint, perpendicular, there. Now what I have to do, unfortunately, is create a point. That's the only thing that whole command will snap to. Point there in the midpoint, and another point there in the midpoint. We'll finish that sketch. Now I can create the hole on that surface. So what we'll do is let's see what a counter bore for a 1032 fastener looks like. So so what we can do is come in here and select somewhere around here. There we go. I knew it was there somewhere. a clearance hole for, and then we can come down here and select our, we want a counter bore. ANSI unified screw, socket head cap, size number 10, fit normal. Okay, we don't want too much clearance on that. So then the only thing we can really do is come in here and zoom in awfully close to that snap point. Now, there's probably a better way to do it. I haven't figured it out yet. And we'll see. That goes way too far down through the surface. It doesn't look like a counter bore is going to work. So we're just going to make a normal hole, a simple hole. What we can do is zero that out, zero that counter bore out. Oops. There we go. So depth. So we just want to make sure the object's to cut. We can keep them both in there for now. It's not that big of a deal. So we'll cut both the mounting bracket and the aluminum uprights, so that's fine. So you can see here, this is our. Let me turn the sketch off. So that's the mounting foot, and then that's the aluminum. All right, we'll turn that sketch back on, make the other hole. Oops. Here we go. I figured it out. H for hole, and I come over here, put it there, and then we'll come back and we'll do a clearance just to get our sizing right. ANSI unified. Socket head cap screw, number 10. So it's a clearance hole, it's a simple. Go down 10 millimeters. Objects to cut, both parts, and hit OK. So there we go. Now, we could I still don't know how we could get a fastener down there. And we want to avoid coming in on the sides of these, because you got to remember we've got belts in there as well. We could possibly space the belts out, space the pulleys out a little bit, and get a way where we could wrap around this surface. But for now, I'm thinking this is probably going to be the only way. That might be something we could do later on, figure out a way to do that. But for now, this is kind of how we're sticking. Okay, so the last thing we need to do before we can start copying this down and finishing the arm is create a bolt hole. So what I had envisioned for securing all this to the aluminum was a single bolt going through here, but a whole bunch of epoxy inside. So essentially what we would end up with is the bolt would be there for most of it, but the epoxy almost is like a fill in the blank type of thing. So let's do that. So to find the actual center of this little the part that the aluminum is engaged in, I'm going to make another drawing here. So I'm going to project. I'm going to project onto that surface. I'm going to project our aluminum and hit OK. The other thing I'm going to project is that edge as well. I'm going to show you a little trick about how to find the exact center of this island. What I'm going to do is I'm going to come down from one end to where the other end. So the midpoint of that line is the exact center of our of that area. So I'm gonna create a point at that midpoint there. Finish the sketch. So now I'm gonna come through and create a hole there. And then we're gonna go back in here. It's a simple hole clearance for a number 10. And this time what I'm gonna do is go all the way through. So now we have a hole in our aluminum and our mounting foot. There we go. If I turn off the foot, there's our mounting hole. Okay. Now, if all the geometry worked out correctly, when I go ahead and copy this down, everything should line up. So what I'm gonna do is I'm gonna select our mounting foot or pad, whatever you want to call it, and then I'm gonna move copy. This time I'm gonna set the pivot directly in the center of this top surface of our aluminum. Okay, and once I finish that and I rotate, I need to create a copy. And then I rotate this all the way down 180 degrees. You can see we are perfectly on the surface of our belly pan. So we did it right. Okay. Now, the other thing we could do is if we wanted to project, we wanted to make the hole down in this side of the tube, yeah, let's do that. We'll project this hole onto there. We'll project that hole. We'll turn off the body. We will finish the sketch. We'll extrude that hole all the way through and hit OK. Okay, so there's one of our triangulated pieces. So now the only thing we need to do is copy it over. I'm sensing it's going to hit our radio, which isn't that big of a deal. We got plenty of room. We can move that. So the last thing we'll do is we'll create some copies of those new parts. So I selected those three, just control clicking, and we'll move copy. And now all we have to do is a point-to-point move from there to there, and it didn't create a copy. There we go. And we'll hit OK. So there's our triangulation for the uprights. Let's turn everything back on and see how it looks. So let's dissolve all of those. And we'll turn on our intake. We'll turn off our section. Don't see any major interferences. The only thing could be, the only risk here is, I'm gonna actually highlight those. The only risk is really if when we intake a part or a cube, there's a slight risk that it can come down and hit those as well, but I'm not super concerned about that. But other than that, the triangulation looks pretty darn good. Yeah, I'm happy. Okay, so what's left? I think what I'm gonna do is some minor little housekeeping type stuff. I'm not gonna show the video for it or make a video on it. I might do one little thing and show you, But like for example, the fasteners, where we got the fasteners got lost in the whole do we shrink this down discussion from I think video probably 6 or 7, I don't remember. So we lost some of the fasteners. And then the other thing is, now that we've got this cool robot, how do we make it look cool? I'm gonna do some of that stuff offline. I think the next video will probably be the end of the series, and we'll go into how to make this robot look cool in your documentation. So so you're thinking like engineering notebook, what can we do? Again, this is FRC specific. Your engineering notebook, the stuff you can go back and document how you went about developing the robot. So again, more offline stuff probably, and then the next video will be making it look cool.